Okay, so here's the next example. So once again, a parametric equation is basically equations that have t in it, and so we have a t in here for each one. That's a t right there, and we're given t values are going to be from 0 through 4. So t values can change. They can be negative, positive, or 0. So in this case, they just want us to do 0 through 4. So once again, I'll let you know what values I want you to do in a test, and also online they'll have you fill in a table so you know exactly what the t values are. So we're going to fill these in here. So same as we did before. What you do is you put the t value into here. That's going to give you your x value. You put the t into this one. That gives you the y value. Then you get a coordinate. So at every single time, we'll see where exactly the point moves to where it actually is. And once again, we always want to make sure that we indicate the direction that the point's moving when we do the graph. So let's first start by filling in the table. Okay, so this is 0, so square root of 0 is 0. This is 1/2 times 0 plus 1, that's going to give you 1. So 0, 1 is where the point begins. Next, square root of 1 is 1. We do 1/2 times 1 plus 1 there. That's 1/2 plus 1 is 3/2. So I have 1 comma 3/2, or for graphing purposes I can think of that also as a 1.5, but I'll go ahead and use fraction notation here. Next, square root of 2. Okay, that's about all I can really do for simplifying purposes. Now as a decimal, that's going to be 1.41, which maybe we can refer back to later, but I'll still go ahead and use the exact value there for x, square root of 2. Then I have 1/2 times 2 plus 1. 1/2 times 2 is 1. 1 plus 1 is 2. So then I get 2 is going to be the second coordinate there. Next we're going to do square root of 3. Square root of 3, that's about 1.7 if you do that in a calculator. So again, when I write the answer, usually those online homework grading programs, they usually prefer the exact value, so I'll go ahead and keep that as square root of 3. And then I have 1/2 times 3 plus 1, that's 3/2 plus 1, which is 2/2. So when you add that together, you get 5/2. So 5/2 would be that one. Again, if I want to write this as a decimal, I could, and I could write that as 2.5 if I wanted to, but this would be the exact point here. And then I have square root of 4, which is going to equal 2. Then I have 1/2 times 4 plus 1, and you get 3. So 2, 3 is the last coordinate. So this is, again, filling all the table, filling everything all in. We should get these set of points. These are the ones that we're actually going to graph, and we're going to pay close attention to, again, which direction the point is moving. So we're going to start with the point 0, 1. So again, if you need more time to write that down, go ahead and pause the video and rewind it. So I'm going to go ahead and erase this so that way we have some room to draw the graph. So drawing the graph, okay, we'll do that right here. And because all the points are positive, let me move it over. And I'm going to use a bigger scale here for this one. So go ahead and use this, make it blown up here. Okay, so the first point is 0, 1. That's going to be right here on the y-axis. Next point is 1 and 3/2. That's also the same thing as 1.5. So 1 and 1.5 is right here. Next, I have root 2 and 2. Root 2 is 1.4, and 2 would be about right here. Move it over a little bit more, probably about right there. Then I have square root of 3. Square root of 3 is 1.7. 1.7 is here, and 2.5 would be right there. That would be the y value, so that point's about right there. And then finally we have 2, 3. 2, 3 is here. So it looks again like it could be a parabolic shape, or it might even be exponential. We're not really sure until we actually eliminate the parameter. So here, this is the graph, and we notice that we started here, and the graph, it went this way. We had our t values from smallest to largest, and that was the direction that the point went. So I got this little arrows on it indicating that that's the direction of movement. So that would be the graph that would go along with these set of points. Now that's complete. We're ready to eliminate the parameter, and we'll see what kind of graph that we get from this. Okay, so here was our two equations. X is equal to the square root of t, and the y is equal to 1/2 t plus 1. Alright, so now we have this. We need to do, again, substitution is the way that you want to solve this. So I'm going to take the first one, solve it for t, put it in the second one. This one, if I solve for t, I would get some fractions involved, so it might be easier to work with the first equation. Now the first equation, you can square both sides. If you square both sides, you get the radical to go away there, and you get x squared is equal to t, and then you can take this one and put it into the bottom one. So then we get y is equal to 1/2. Instead of t, we put in x squared. That eliminated the parameter. We got rid of the t, and now we have this. So we find that this is actually another type of parabola on this because we get the x squared. So again, if I wanted to graph this one out using a regular graphing system, it would look exactly like this. I would probably have the full complete parabola on both sides, but again, the t values will tell you, they kind of limit you to only what part of the graph that you actually see. So because we only graph between 0 and 4 for t values, that's the only part we saw. The graph starts there, ends there.